In this imaginary scenario, Jim is driving a Jetsons flying car at a constant speed of 100 miles per hour. We need to determine approximately how long it will take him to arrive at the nearest star from Earth, Alpha Centauri, which is about 4.4 light years away. So the formula is actually very simple. Distance equals to speed times time, and we are given the distance, 4.4 light year. We are given the speed, which is 100 miles per hour. We need to find time. Therefore, the time is simply distance divided by speed. The difficult part here is that the distance is given in an unusual unit, light year. Therefore, we need to do some unit conversion first. So light year is the distance traveled by light in a year. And here the speed of light is given as 3 times 10 to the 8th power meter per second. Therefore, we're going to first convert light year into kilometer, because we can easily convert between kilometer and meter. So 1 light year is the distance traveled by light in a year. Therefore, that's going to be the speed of light, 3 times 10 to the 8th power meter per second multiplied by 1 year. Year and second doesn't cancel out. Therefore, we need to use unit conversion to convert year into second. So we're going to put 1 year here on the denominator so that they can cancel out. And that'll be 365 days in a year times 24 hours in a day times 60 minutes in an hour, and lastly 60 seconds in a minute. Okay, and then year and year cancel out, second and second cancel out. So the result given in scientific notation is going to be 9.4608. Let me keep 5 significant figures for now, because this is an intermediate step, times 10 to the 15th power meter, and that equals to convert that into kilometer, 9.4608 times 10 to the 12th power kilometer. So that's 1 light year. Of course, if the distance is 4.4 light year, we need to multiply this distance by 4.4. And then the speed is 100 mile per hour. And we are given the unit conversion between mile and kilometer. Therefore, that equals to 160.9 kilometer per hour. So now we're ready. The total distance D equals to 4.4 light year multiplied by 9.4608 times 10 to the 12th power kilometer per 1 light year. So that equals to 4.16 times 10 to the 13th power kilometer. Therefore, the time equals to distance over speed. That is going to be 4.16 times 10 to the 13th kilometer over 160.9 kilometer per hour. Kilometer cancel out. What's left is going to be 2.59 times 10 to the 11th power hour. And then you can convert hour into year. So the same thing. You want to have 1 year on the numerator. On the denominator, 1 year is 365 multiplied by 24 hours in a day. Therefore, hour and hour cancel out. What's left is year. That'll be 3 times 10 to the 7th power year. And that's keeping 1 significant figure. And you can report that as your final answer. or to put it in common language, that'll be 30 million years.